Okay, this is the continuation of examples that we were working on in class when dealing with graphing polynomial functions. I did this one in one class but not the other, so we're going to start with part C. So this is section 4.1/4.2/4.3 because it was all kind of mixed together. First thing is this one's already factored, so we can go ahead and list our zeros, which would be a -4, a +2, and a +6. Just imagine setting each of those to 0. If we use the chart method, we would then place these on the number line from least to greatest. You could also use the behavior method that I taught you in class, but I'm going to try to stay consistent with what we've already kind of used this semester. So this would be -∞ to -4, -4 to 2, 2 to 6, and 6 to infinity. You do have to be careful here because of this -1/8 out front. It does affect your sign. So when you go to pick your test values, the first thing you should write underneath here is all the factors including the -1/8. I know there's not an X there, but it still has to be included because it changes the sign. So we list all of our factors. We're going to pick our test values. So I would pick -5, maybe 0, +4, and 7. This -1/8 is just going to make everything negative. -5 plus 4 is negative. -5 minus 2 is negative. -5 minus 6 more is negative. 4 negatives make an overall positive, which means this will be above the x-axis. 0 plus 4 is positive. 0 minus 2 is negative. 0 minus 6 is negative. 3 negatives make a negative, which means this will be below. 4 plus 4 is positive. 4 plus 2 is minus 2 is positive, and 4 minus 6 is negative. 2 negatives make a positive, so this one will be above. And 7 would be positive, positive, and positive, but the negative at the top makes the thing overall negative, so it'll be below. The good thing about doing this by the chart method is that you've already answered the question, when is f of x less than 0, and when is f of x greater than 0? The less thans have to be the negative cases, so that's these two intervals, just to highlight that. And then the greater thans would be the plus cases, so that goes with that. So we just need to write out those answers and then we'll go graph it. So -4 to 2 union with 6 to infinity, and -∞ to -4 union with 2 to 6. We're going to place our x-intercepts on our graph. So we have -4, +2, +6. To the left of -4 we are up. To the right we are down, but eventually you're going to come back up, and it might help us to find the y-intercept. Sometimes that helps you guide your point. That just makes all the x's 0, so essentially just the numbers are left. Since these are all just 0 plus 4 is 4, 0 minus 2 is -2, 0 minus 6 is -6. If there had been an x out front, though, the whole thing would have ended up being 0, but luckily we didn't have that. So this is -1/8, but this is -8, so that actually makes a +1 times a -6, which is -6. So I know I'm supposed to cross the y-axis some point before heading back up. At 2, I'm supposed to be above the x-axis, and at 6, I'm supposed to end up below the x-axis. So that's just a generic graph of what this would be doing. All right, let's look at D. On part D, you have to factor first. So we would pull out, especially if you're going to use the chart method, we would pull out and factor by grouping because it's 4 terms. I would pull out an x squared out of the first pair and a -9 out of the second pair. I notice I get x squared minus 9, which will factor again, and an x minus 3. X squared minus 9 is an x plus 3, x minus 3, but we already had an x minus 3, so that guy's going to be x minus 3 squared, which means he is a multiplicity of 2. So my zeros are -3 and 3. Put them on the chart. My intervals would be negative infinity to negative 3, negative 3 to 3, 3 to infinity. My test values, I could use negative 4, 0, and 4. So then when we plug those in, well, we have to be careful here. You can either list out your factors separately, or you could list the x minus 3 as a squared part, but you must be careful when you plug into that then. So I'm going to list them separately. So negative 4 plus 3 is negative, negative 4 minus 3 is negative, so that happens twice. So that's 3 negatives, which is an overall negative. So that means we are going to be below. 0 plus 3 is positive. These two will both be negative. Two negatives make a positive, so we're going to be above. And 4 ends up making all of them positive, so we're going to be above again, which means we have a bounce right here if you stay the same sign, which makes sense because this had a multiplicity of 2 is even, which means you have a bounce. So that's, remember, another way you could have graphed this. Okay, let's go ahead and write our intervals. F of x is less than 0 from negative infinity to negative 3. F of x is greater than 0 from negative 3 to 3, union with 3 to infinity. We don't use brackets, remember, because if you use a bracket, you're saying equal to 0, and we're not saying that. We're saying anything either above or below. So negative 3, positive 3, we are down on the left. We could find our y-intercept, but it's like 0.27, because if you plug in 0 for all of these x's, so this is going to go way off the grid, and I'm just drawing it the best that I can. Way up there somewhere, then come back down, and it's going to bounce. So it's going to go back up. So way up here somewhere would be 0.27. Okay, let's look at part E. So for part E, you are supposed to try to factor it first to see if it factors. I would probably pull out a negative. I would make that x to the 4th minus 12x squared plus 27. That means we can use same signs now. So we can think of factoring this into an x squared and an x squared, or we could use substitution if we want. And it looks like a minus 9 and a minus 3. The minus 9 factors again into x plus 3 and x minus 3. The x squared minus 3 does not factor, but it will give us some intercepts, essentially. So there's a negative 1 out front. So my zeros are, the negative 1 doesn't give you any zeros because it doesn't have an x on it, but you'd have a negative 3, a positive 3, and then we have to solve this x squared minus 3 equals 0. So you're taking the square root, so you get a plus or minus the square root of 3. So the first time we've had kind of an odd number show up as one of our intercepts. So this would be, let's see, negative 3 would be smaller than negative square root of 3. Then we'd have square root of 3, and then positive 3, test values of negative 4. We could use negative 2 here, I believe. Yep, because square root of 4 would be 2. Here I would use 0, positive 2, and positive 4. We have to list our factors. We had a negative 1 that needs to be considered. We have an x plus 3, x minus 3, and an x squared minus 3. Be careful with that x squared minus 3. Because there's a minus at the end, some of those could still turn out negative even though you're squaring. So negative 4, well actually the negative ones all create negatives across. Negative 4 plus 3 is negative, negative 4 minus 3 is negative. Negative 4 squared is 16, minus 3 would be 13, so that's positive. 3 negatives make a negative. Negative 2 plus 3 is positive, negative 2 minus 3 is negative. Negative 2 squared is 4, minus 3 is positive. 2 negatives make a positive. 0 would be a plus, a minus, and a minus. So that would be another negative. 2 would be positive, negative, and positive. So that would be another positive overall. And then 4 is positive, positive, and positive. So an overall negative because of the negative on top. So we're going to plot this pretty quickly. So we have negative 3. Negative square root of 3 is somewhere between negative 1 and negative 2. So just estimate kind of where you think that would be. Same thing over here. Between 1 and 2 is going to be square root of 3. And then we need the positive 3. And we are going to need, I'm going to get our y-intercept would be 0, negative 27, since 0 would make these guys go away and just leave that. So somewhere way down here on the y-axis at 0, negative 27, we'll have a point. On the left side of negative 3, we're down. On the middle between negative 3 and negative square root of 3, we are up, and then come back down. We then go all the way back down somewhere low, 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 and get this intercept. We come back up between 2, or 1, sorry, excuse me, square root of 3 and 3, we go back up. And we don't know if it's the same height or not, and then we go down. So f of x was less than 0 at negative infinity to negative 3, union with negative square root of 3 to square root of 3, union with 3 to infinity. F of x was greater than 0 from negative 3 to negative square root of 3. That's supposed to be a negative. That did not show up negative. I'm going to rewrite that. What? Okay, it doesn't want to go away. It's negative square root of 3. And then union with square root of 3 to positive 3. Okay, f is the last of the polynomial functions that I'm going to graph for you guys. So we have, this one is already factored. So our zeros are, anytime it's just an x out front, the 0 of 0 is actually there. Negative 1, 2, and 4. So we put those on our number line from least to greatest. Oop, that was not enough space. 0, 2, and 4. Intervals would be negative infinity to negative 1, negative 1 to 0, 0 to 2, 2 to 4, and 4 to infinity. We have to put all of our function over here on the side for our test value to be tested. So x cubed, x plus 1 squared, x minus 2, x minus 4. Test value for this region, I can use negative 2, negative 0.5. This one would be a positive 1. That would be 3. And this could be 5. So we're just picking our test values. If you cube a number, it stays negative. So those both will be negative. If you cube a positive, it'll stay positive. So those are positive. Be careful here. Whatever you do, you add it to 1 and then you square it. So those are going to come out positive all the way across. X minus 2, that would be negative for this one. X minus 4 would be negative. So 3 negatives make an overall negative. Negative 0.5 minus 2 would be negative. Negative 0.5 minus 4 would also be negative. So 3 negatives make a negative, which means there's a bounce here, which makes sense since that's squared. 1 minus 2 would be negative. 1 minus 4 would be negative. 2 negatives makes an overall positive. And then we'd have a positive and a negative, which is an overall negative. And then the last group would have both of these being positives as well, so the whole thing would be a positive. So f of x is less than 0 for these 3 intervals where you have a negative. So negative infinity to negative 1, union with negative 1 to 0, union with 2 to 4. F of x is greater than 0 from 0 to 2, union with 4 to infinity. Now we just need to graph these. So negative 1 and 0, which is right here. and 2 and 4. Okay, we are down on the left, but we are also down on the right of that, so that means we go down some unknown amount. Oops, that's not a good drawing. You have to stay between the 2 points. And then it hits this again and goes up, comes back down eventually, goes back through, goes down, and goes back up, and then goes up forever. So just following the path of the signs. Okay, I did a long division problem on the very end of class, so I'm going to do another one just to make sure we have the idea. In fact, I have a couple left. I'll save the remainder theorem for next time, but we can do some of the long division. I'll save at least one of them for next time as well. So this is 2x squared plus x into, now we need to make sure we're not missing any pieces. Oh, it's a horrible drawing. So this is cubed, squared, first power, and no x. That's in a perfect order. Everything's already lined up. So we ask, what do you multiply 2 by to make 3x cubed? So anytime you can't make this number into this one, there's a trick. You use the, let's see, we would need to use the number we're trying to cancel out as our denominator and the number we want as our numerator. So if we multiply 2 by this, that will, notice, cancel out the 2's and just leave you the 3. So 3/2 x times 2x squared would be 6 over 2, so that would be 3x cubed. And then this we have to multiply as well, so that would be positive 3/2 x squared. And then we need to change all signs because in long division we change signs before we actually combine. That makes this cancel out. This guy would need a common denominator, -5. Remember, it can be written as -10 over 2. So -10 minus 13 would be -13 over 2 x squared. Bring down everything else so it doesn't get lost. And then now we have to ask ourselves, what do you multiply this by to get this? Well, it's a little harder because you need to end up still having a 2 in the bottom. So you need at least 2 2's in your original bottom. So I went with a 4. Because 2 and the 4 would reduce and leave you with the half. And because this is negative, my sign up here needs to be negative. So now I'm going to multiply this by everything out front. That would make -13/2 x squared. And then -13/4 times this would be -13 over 4 x. Oh, this one was supposed to be not. This one was not supposed to have the x. Sorry, I got misleading when I wrote that in there, because when you write your answer up here, this degree should be getting smaller by 1 as well. So sorry, just a little side journey. So now I changed my signs. So this one was negative, so it's actually going to now become positive. This was also negative, so now it's going to become positive. So this means that these cancel out, and this would be, we need a common denominator again. -4 over 1. Equals, let's times it by 4 on top and bottom. That's -16 over 4. So we're doing -16 over 4 plus 13 over 4. So if we add them together, that's -3/4. And then our final step cannot be accomplished because x squared cannot go into x. So my quotient was 3/2 x minus 13 over 4. My remainder was -3/4 x minus 8. Let's do at least one more, and I'm going to do, well, I'll do C. In C, you're trying to divide f by p. As soon as you start lining this up, though, you notice that this one goes away pretty quickly. First of all, we need a placeholder for the 0x. But you can't make something bigger cannot be made smaller when we're doing long division. That's by exponents. Cannot be made smaller here. So that means this is actually a no solution case. Okay, that leaves us with just 3 examples to finish up on Monday on this part, but I am going to do a little pre-video on some other stuff that we're going to cover in class.